Okay, so we're going to start reviewing for your second test of the second quarter. That's going to be on December 2nd. Your review sheet should have been completed Wednesday, which is December 5th. Extra helps after school on Wednesday, December 5th. And then your corrections are due on December 7th, the day of that test. Okay, so for numbers 1 through 3 wanted you to find when f of x equals g of x. If you remember, I told you that f of x equals g of x. I only care about the x values for this. I only care about the x values. And it says rounded to the nearest thousandth. You'll notice in your directions, the word that is missing that would require a lot of your own work is algebraically. So what I'm going to tell you to do is type this into y1, type f of x into y1, and then g of x into y2. So take a second now and pause the video and type that into your calculator if you have to. Now, if you're looking at your standard window, it's actually going to look something like, oops, that's not what I wanted, something like this. So if this is my axes, you can kind of see how you have a little min at the bottom, and then that comes up. That was g of x, and then f of x looks something like that. So I need to figure out what this point of intersection is. I don't really need the point. I really need the x value of that point. So if I press second and then trace, number 5 is intersect, and then I hover over that point, and I just press enter 3 times. It gives me that point, but I only care about the x value. So my answer here is x equals, I'm rounding to the nearest thousandth, 3.662. I only have one point of intersection here. Even if I blow out my window and I'm looking now at more of the graph, I still am only going to see one intersection point. I'm going to do the same thing for number 2 and for number 3. For number 3, if I look at my graph, I have, this is my radical, and then here I have a parabola. So here I actually have 2 points of intersection, so I have to do second trace number 5 2 times here. So when I do it the first time, again, I only care about the x value, and I'm rounding to the nearest thousandth. I get x equals negative 1.264. And if I do it for the second one, so I have to go through and do second trace again. It doesn't just automatically know what you want to do once you get one of them. That gives me x equals 3.047. Okay, again, I don't care about the y values. And then for number 3, I'm going to take a second now, pause it, type that into my calculator. So now this one, both of these are parabolas. So one parabola comes up like this, and then the other one comes way down low here like this. So this is one and this is the other. So I have this point and I have this point. This bottom point right here that I'm coloring, actually you can't see it in your standard window. So if I go to my window and I make my y min go down even lower, so maybe negative 30, if I look at my graph now, I might be able to actually see that point, which I can. So my first one, if I do second trace number 5, that first one, so the lower one that I just extended my window for, is going to be x equals negative 3.130. And the other one, second trace number 5, is going to be x equals 2.130. Again, I'm rounding to the nearest thousandth, but just 3 decimals. For number 4 and 5, I have systems. So here, for systems of equations, I need the x and the y. And then this is algebraically. So this was a heavy emphasis on the last test. So for this one, I am going to, I have f of x is this and g of x is that. So this is a quadratic linear. So I'm going to set them equal to each other because really this is y equals and this is y equals. So negative 2x squared plus 4x minus 1 is equal to 2x minus 5. I'm going to bring everything to the right. That way my x squared term becomes positive, but not a big deal if you bring everything to the left. So this is 2x squared. When I subtract 4x, 2x minus 4x is negative 2x. And then when I add 1, negative 5 plus 1 is going to be negative 4. If I want to make this easier on myself, I can divide everything by 2. So now this is 0 equals x squared minus x minus 2. If I go through and do master product on this, my final result is x minus 2 times x plus 1. So my x values, I get x equals positive 2 and x equals negative 1. So now, when I go through, I have to find the y values for these. I'm going to plug them into my linear because it's going to be a little bit easier for me. So when I plug them into my linear, I'm going to do y equals 2 times 2 minus 5. That gives me y equals 4 minus 5 is negative 1. So that point is 2 comma negative 1 as one answer. And then the other one, y equals 2 times negative 1 minus 5 gives me y equals negative 7. So this point is negative 1 comma negative 7. And then if I'm ever asked to justify, I have to do 4 checks. There's 2 answers, one here and one here, and I plug them into this equation and this equation. I plug them into both. Number 5 is a circle linear. So for a circle linear system, here I have x equals already, so I'm going to solve for one variable, which I have. I'm going to take this and plug this in for x. So this is now y plus 4 squared, so it's y plus 4 times y plus 4 plus y plus 2 times y plus 2 equals 4. So this is y squared plus 8y plus 16 plus y squared plus 4y plus 4 equals 4. 2y squared plus 12y plus 20 equals 4. When I subtract that 4 over, 2y squared plus 12y plus 16 equals 0. If I want to, I can divide everything by 2. So now this is y squared plus 6y plus 8 equals 0. I do master product. My end result is y plus 2 times y plus 4 equals 0. So I get y is equal to negative 2 and y is equal to negative 4. I need the x values though. X is equal to y plus 4. So y is negative 2 plus 4 gives me that x is equal to negative 2 plus 4 is 2. So this point is 2 comma negative 2. My other point, I have x is equal to y plus 4. Negative 4 plus 4 gives me 0. So this point is 0 comma negative 4. If I am asked to justify, then you have to plug both points into both equations. Then we have more systems. So number 6 actually got split up a little bit strangely, but that's okay. So for number 6, we have a 3 by 3. So if you remember with 3 by 3s, you have 3 equations, 3 variables. You do 1, 2, elimination on equations 1 and equations 2. Then you do elimination again on equations 1 and equations 3, getting rid of the same variable. And that gives you equations A and B. Then you do elimination on A and B. So let's see what this actually happens here. So equation 1 and equation 2. This is negative x plus y minus z equals 1. This is negative x plus 7y plus 5z equals 1 also. I am going to get rid of, if I look at my x's, this looks pretty easy to get rid of them. So I'm going to multiply my top equation by negative 1. That way my signs change, and when I add down, then they're going to actually cancel. So this is x minus y plus z equals negative 1. And the other one is still negative x plus 7y plus 5z is equal to 1. So when I add down, my x's cancel. Here, this gives me negative 1y plus 7y is 6y plus 6z is equal to 0. That is equation A. For equation B now, I'm going to do elimination on 1 and on 3. So this is negative x plus y minus z equals 1. And my other one is x plus 7y plus 7z is equal to negative 9. Here I already have additive inverses. I have to get rid of x's here. So I can add straight down. Negative x plus x cancels out. I get 8y, and then plus 6z is equal to negative 8. And this is equation B. So now I'm going to do elimination on A and B. So I take A, and I take B, and I have to do elimination again. So my z's, I think, would definitely be easier for me to eliminate. So I'm going to multiply this top one by negative 1. So this is now minus 6, and 0 times negative 1 is just 0. So now when I add down, I get 2y, this cancels, equals negative 8. So y is equal to negative 4. So now that I have y equals negative 4, I then am going to work backwards. I know that 6 times y, so 6 times negative 4, plus 6z is equal to 0. So negative 24 plus 6z equals 0, so 6z is equal to 24, which means z is equal to 4. And then lastly, I have negative x, I need my x value, negative x plus y, so minus 4, minus z is now minus 4, is equal to 1. So negative x minus 8 equals 1, negative x is equal to 9, so x is equal to negative 9. So then this point is negative 9, comma, negative 4, comma, 4. Okay, the second part to this question, I'm only going to do this for this first one, but you need to know how to do this for your exam. To justify, I'm going to take my original 3 that I have here, and I'm going to plug in x, y, and z, and it should all work out. So I have to do that though for all 3, so there's 3 checks for this. So this is negative x, so this is going to be negative 9, plus y is negative 4, minus z is 4, and that should equal 1. I'm going to take a second now and plug this left side into my calculator. I get 1 equals 1. That checks out. Then I'm going to do the second equation. So negative x plus 7y plus 5z should be equal to 1 as well. I'm going to type this into my calculator. I end up getting 1, which is equal to 1. That checks out also. Last one. X, negative 9, plus 7y plus 7z. That should be equal to negative 9. Take a second, I plug that into my calculator, and I get negative 9, which is equal to negative 9, and it checks out. If one of these does not work, that means that this answer here that we got would be incorrect. Okay, so that's how you do 6. Okay, 7 and 8 I'm going to go through a little bit more quickly. Okay, I'm also not going to justify it just to save time, but my answers do work out when I justified it on my paper. So for number 7, I'm going to do equation 1. And equation 2. And I'm actually going to get rid of my y variable. I think this would be the easiest track for me to do. If you don't get rid of y, though, that's totally fine. You should still end up with the same answer that I get, just a little bit in a different way. So to get rid of y, I'm going to multiply the bottom equation by negative 4. So now the top stays as 2x plus 8y plus 7z is equal to 5, and the bottom is now negative 4x minus 8y minus 8z is equal to 12. When I add down, I get negative 2x, this cancels, minus 1z is equal to 17. That is equation A. Equation B, I take by doing 1 and 3. I have to get rid of my y variable again. So plus 8y plus 7z. 7z is equal to 5. So to get rid of my y variable, I'm going to multiply the bottom by 8. So the top stays the same, 2x plus 8y plus 7z is equal to 5, and the bottom is 40x minus 8y minus 40z is equal to 16. When I add down, I get 42x, middle cancels, then negative 34z is equal to 5 and 16 giving me 21. That is equation B. So now I do elimination on A and B. So A is negative 2x minus z is equal to 17, and B is 42x minus 34z is equal to 21. I'm going to, you can do either elimination. I'm going to get rid of my x's, so I'm going to multiply this by 21. So this is now minus 42x, and then minus 21z is equal to 21 times 17, which is 357. 42x minus 34z is equal to 21. When I add down, these cancel. Negative 21z and negative 34z give me negative 55z is equal to, wait a second, something went wrong here. This should have been, let's fix this. When I added this down up here, I should have gotten negative 7 minus 40 gives me negative 33. Sorry about that. So this is negative 33, this is negative 33, this is negative 33, and this is negative 54 then. Negative 21 and negative 33 give me negative 54. And then when I add these two down, I get 378. So z is equal to negative 7 when I type it in. So now I have 1, so I can work backwards to plug it in. So I'm going to plug this into equation A. So negative 2x minus z is equal to 17. I get negative 2x is equal to 10. So x is equal to negative 5. So now I know we have negative 5 comma something comma negative 7. So I plug x and z into one of the originals, and it will give me y. So 2 times x is negative 10 plus 8y plus 7z gives me minus 49 equals 5. So 5 plus 10 plus 49 gives me 8y is equal to 64. So y is equal to 8. And this is my answer. Again, if I were to justify, I would have to do 3 checks. Okay? And then lastly, number 8. So number 8, I'm going to choose to get rid of my x values. Y would be pretty easy too. Z would be a little bit more work, but x and y pretty much have the same level of difficulty. So equation A, equation B. So I'm going to multiply my bottom equation by -1. So this is going to be plus 5x plus and minus. So that when I add down, my equation A is going to be -6y plus 5z is equal to -12. And that is equation A. For equation B, I'm going to take 1 plus 4z is equal to -2. And equation 3, again, I have to get rid of x again. So I'm going to multiply this bottom equation by 5. So this stays the same, minus 5x minus 9y plus 4z is equal to -2. And then the bottom now becomes 5x minus 45y. This is a 5, not an 8. 45y plus 25z is equal to -10. When I add down, my x's cancel. I have -54y plus 29z is equal to -2, and -10 gives me -12. And this is equation B. So I take my -6y plus 5z equals -12, and my -54y plus 29z is equal to -12. And I'm going to get rid of my y's because here I would multiply this by -9. So now this is positive. I'm going to bring this down here just to save space. This is 54y minus 45z is equal to positive 108. So when I add down, my y's cancel. 29 minus 45 gives me -16z is equal to -12 plus 108 is 96. So z is equal to -6. Once I have 1, I can then work backwards to plug everything in. So -6y plus 5 times z, so 5 times -6 is going to be -30, is equal to -12. I'm going to add 30, so -6y is equal to 18, which means y is equal to -3. It's 2 parts. My last part, I'm going to plug it into equation 3. X minus 9y, so -9 times -3 is plus 27. Plus 5 times z, so 5 times -6 is -30, equals -2. So -2 minus 27 plus 30 gives me x equals 1. So my answer is 1, -3, -6. 9 and 10, algebraically determine when the following rational expressions are undefined. Undefined is when the denominator equals 0. These should be quick. So x squared minus 16 equals 0. You can do x squared is equal to positive 16. When you take the square root, you get x is equal to plus or minus 4. Or if you wanted to, you could have factored x squared minus 16 using dots. For number 10, 2x squared plus x minus 10 equals 0. You have 3 ways of solving this. The easiest way, in my opinion, would be to do master product. So this is 2x squared minus 10. 2 numbers that multiply to be -20 but add to be a positive 1 are going to be positive 5x and minus 4x. So this is x times 2x plus 5 minus 2x plus 5 equals 0. So this is 2x plus 5 times x minus 2 equals 0. So when is this undefined? When x is equal to -5/2 and when x is equal to 2. Moving on. 11 and 12, simplify the following rational expressions. So this means that you factor everything. You're trying to reduce it. You factor everything as much as possible, and then you are just going to cancel out what they have in common. So for number 11, 2x to the third, we have 4 terms in the numerator. You're going to factor by grouping. You could take out 2x squared, and you are left with x plus 3. and then you have minus 7. You're left with x plus 3. So my numerator is x plus 3 times 2x squared minus 7. My denominator, x squared plus, I have 3 terms, I have to do master product. 2 numbers that multiply to be positive 6 but add to be positive 5 are plus 2x and plus 3x. So I'm going to take out an x. I'm left with x plus 2. Here I'm going to take out a 3. I'm left with x plus 2. So my new denominator is x plus 2 times x plus 3. So when I'm simplifying this, this is really x plus 3 times 2x squared minus 7 divided by x plus 2 times x plus 3. The x plus 3's are what they have in common. That crosses out. You are left with 2x squared minus 7 divided by x plus 2. That is the reduced fraction. Number 12. 12, the numerator should be fairly easy. The numerator, I could take out a 2, and I'm left with 2x plus 1. The denominator, you have to do some work to do to factor that. So this becomes 2x squared, 2 numbers that multiply to be negative 18, but add to be negative 17, pretty easy. Negative 18x plus x minus 9. Take out 2x, left with x minus 9. And then here, take out plus 1, left with x minus 9. So this is 2x plus 1 times x minus 9. My 2x plus 1's cancel. I'm left with 2 divided by x minus 9. That is the reduced fraction. Number 13. Divide each of the polynomials. So here you're going to do long division. Okay, if you know synthetic division, if you're comfortable, you can use synthetic division if the question does not specifically say using long division. So for 13, x minus 7 goes into x to the third minus 13x squared plus 40x plus 18. Remember, if you can do one round, you can do all of them. So x to the third divided by x gives me x squared. That comes up top. Then I multiply. X squared times x is x to the third. X squared times negative 7 is negative 7x squared. Parentheses, subtract. Negative 13 minus negative 7 becomes negative 6x squared. Bring down this 40x. Now I do negative, that's one round. Negative 6x squared divided by x is negative 6x. Negative 6x times x is negative 6x squared. Negative 6x times negative 7 is a positive 42x. Parentheses, subtract. This cancels. 40 minus 42 gives me negative 2x plus 18. Gets brought down. Negative 2x divided by x gives me negative 2. I multiply it back. I get negative 2x plus 14. Parentheses, subtract. These cancel. 18 minus 14 gives me 4. So that this here is my remainder. So I'm going to write this as x squared minus 6x minus 2 plus my remainder is 4 divided by my divisor is x minus 7. Number 14. Same idea. So here I'm going to do x minus 1 divided by 7x to the 4th. Again, I have all my exponents. They're all included, so I don't have to worry about any placeholders. So the 7x to the 4th minus 10x to the 3rd. And I believe you actually have something interesting kind of happening here. So let's do the first round. So 7x to the 4th divided by x gives me 7x to the 3rd. I multiply it back. I get 7x to the 4th minus 7x to the 3rd, parentheses, subtract. These cancel. Negative 10 minus negative 7 is negative 3x to the 3rd. Bring down this plus 3x squared. Negative 3x to the 3rd divided by x is negative 3x squared. I multiply it back, I get negative 3x to the third plus 3x squared. And look what happens when I subtract these. This cancels and this cancels. And I get 0x squared. Don't let that bother you, just keep doing what you're doing. Plus 3x. So 0x squared divided by x is going to be 0x that you're going to put up here. Just keep with the same pattern. So when I multiply this, this is 0x squared plus 0x. Parentheses, subtract. These cancel. 3 minus 0 is 3x. Bring down the minus 3, and you're out of the woods with that 0. So now I do 3x divided by x gives me plus 3. So now this is 3x minus 3, parentheses, subtract. I get remainder of 0, which means that x minus 1 is a factor of that. So my final answer, though, I have to write this as 7x to the third minus 3x squared. You don't need the plus 0x, but you need the plus 3. Okay, and that's it. That was actually kind of a good one. It's an interesting one. All right, 15, almost there. Algebraically show that f of x is a factor of g of x. So I have to show that when I do long division or synthetic division, I get a remainder of 0. Okay, that's the main way that I showed you how to do that. Then you're going to rewrite g of x as the product of linear factors. So first, let's do 15. So 15, I have to do x minus 6 dividing 2x to the third minus 19x squared plus 38x plus 24. So 2x to the third divided by x gives me 2x squared. I multiply this back, I get 2x to the third minus 12x squared, parentheses, subtract. This cancels, negative 19 minus negative 12 becomes negative 7x squared. I bring down the plus 38x. Negative 7x squared divided by x gives me negative 7x. Multiply it back, I get negative 7x squared plus 42x, parentheses, subtract. This cancels, 38 minus 42 is negative 4x. I bring down the plus 24. Negative 4x divided by x gives me negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 6 is plus 24. Parentheses, subtract. You get a remainder of 0. Because you get a remainder of 0, that means that this here is a factor of this whole long thing. So now the next question says to rewrite g of x as the product of linear factors. So rewrite this as the product of linear factors. If you try this the way that I showed you to a few months ago, by actually factoring it using, in this case you would probably try grouping, it ends up not working out. So you have to think of this as a different way. You have to think of this as x minus 6, your divisor, times your quotient. And now you're one step forward, one step closer to linear factors. So now, though, this here, this is not linear because this is 2x squared. This is a quadratic. X minus 6 is good, but I have to keep factoring this. So I factor this using master product. So this is going to, I'll put this over here, 2x squared minus 8x plus x minus 4. So this is 2x times x minus 4 plus 1 times x minus 4. So my factors, this here becomes 2x plus 1 times x minus 4. And this is my product of linear factors. I'm not going to multiply anything. If I multiply it, I'm going to end up back up here, so there's no point. Okay? Just do what the question asks. And then 16. Same idea. So I'm going to do long division first. I should get a remainder of 0. So x plus 3. And I'm putting this into 3x to the 4th. Okay. 3x to the fourth divided by x gives me 3x to the third. Multiply it back, I get 3x to the fourth plus 9x to the third, parentheses, subtract. This cancels. 13 minus 9 is 4x to the third plus 9x squared. One round. 4x to the third divided by x gives me 4x squared. I multiply it back. I get 4x to the third plus 12x squared. Parentheses, subtract. This cancels. 9 minus 12 is negative 3. X squared minus 13x. Negative 3x squared divided by x is negative 3x. Multiply back, I get negative 3x squared minus 9x, parentheses, and subtract. These cancel. Negative 13 minus negative 9 becomes negative 4x. Bring down that minus 12. Negative 4x divided by x gives me negative 4. Multiply it back. Negative 4x minus 12, parentheses, subtract. Cancels, cancels. I get remainder of 0 like I'm supposed to. Now, rewrite g of x here as the product of linear factors. So instead of trying to factor it, I already know two factors, and then I just have to keep factoring them until they're both linear. X plus 3 is already linear, and then I have 3x to the third plus 4x squared minus 3x minus 4. So on the right, I can keep factoring this. This becomes x squared times 3x plus 4. And this is minus 1 times 3x plus 4. So this is x squared minus 1 times 3x plus 4. And then you still have that x plus 3. This is not linear factors, though, because you have this x squared. So you should be able to do something to x squared minus 1. That something is dots. So x plus 3 stays. X squared minus 1 becomes x plus 1 times x minus 1. And then you have times 3x plus 4. These are your 4 linear factors. Whoa. Okay. Number 17 and 18 are rational equations. If you remember, I told you to factor your denominators. So this is x over 1 minus x over x plus 3 equals 3 over x plus 3. My LCD is going to be x plus 3. So I multiply that on top of all of them. I see what I can cross out to reduce. Here, on my first fraction, I can't do anything, so it's just x times x plus 3 minus. Here, my x plus 3 is canceled. I have minus x equals, my x plus 3 is canceled, equals 3. So this is x squared plus 3x minus x equals 3. I end up with this. I'm going to do master product. My result, so once I finish factoring, I get x plus 3 times x minus 1 equals 0. So here I get x is equal to negative 3 and x is equal to 1. However, when I plug these into my denominators, x equals negative 3. If I plug negative 3 in here, I get 0 as your denominator. Can't have 0 as a denominator because it is undefined. So this is a reject. And my only answer is x equals 1. Okay, don't circle anything. Number 18, last question. I factor my denominators. So this is, don't forget this negative here. This is negative 2 divided by x times x plus 1 plus 2x divided by x plus 1 equals 7 over x. So my LCD is going to be x times x plus 1. X times x plus 1. I'm going to put my factors together in the bottom. So here, this cancels with this with this, I'm left with just -2. Here, this cancels with this, and I'm left with x times 2x, which is 2x squared. And then on the end, x with x cancels it, and I'm left with 7 times x plus 1. So this is 2x squared minus 2 equals 7x plus 7. 2x squared minus 7x minus 9 equals 0. If I go through and I do master product, I end up with 2x minus 9 and this plus 1. 2x squared plus 2, yep. So here I get x is equal to 9/2, which is 4.5 if you want. This is an okay answer, right? If I plug it into my denominators, nothing becomes 0. And then I get x equals -1, which you can see, if I plug that in right here into x plus 1, -1 plus 1 becomes 0. This answer is a reject. So my only answer here is this 9/2 or 4.5. Okay, again, extra help is going to be on Wednesday after school. So if you have any questions, come during that time. Okay, have a good night.